Let's see another example. This is the exercise related to the capitalized worth from sheet number 3. So we are continuing with the sheet, but we still have these two exercises related to the capitalized worth. This is the first one. Find the capitalized equivalent worth for the cash flow series. Here, what do I see? You look here, you see we have a pattern that repeats itself till infinity. In this pattern, we have at the first year 200, second year 200, then at third year 100, and the fourth 100. It will repeat itself. So if you look here at year 5, 6, 7, 8, I have 200, 200, 100, 100, and the pattern will repeat itself till infinity. And I want to see what is the capitalized worth of it at 10%. So the first step in our solution is to change this part, which is the repeating pattern, into an annuity. This is your first step. Always with the capitalized worth exercises, if you get the value of A, you can right away apply the rule P equals A over I. Now, how do I change these values into A? Because they are different values, it's not an annuity. The easiest method is to get the present worth of those payments, and then when I get P, I can change it into A. Then this A, I'll put it in the formula P equals A over I. So normally I will get the present worth. What is the present worth of this 200? It's far away by 1 period, so it's a future value. So I will say P equals F. This is the first 200 into P knowing F, 10, 1, far away by 1 period. This second 200 is far away from the present by 2 periods. So I will say plus 200 into P knowing F, 10, 2. Same here, far away by 3 periods. So 100 into P knowing F, 10%, 3. And this is far away by 4 periods. So I will treat each arrow as a future value, and I will get its present value. The total present worth will be $490.5. So now I got the present worth. Can't I get its annuity? P equals A into P knowing A, 10%, 4, because I have 4 payments. So out of this equation, I will get the value of A. So A is 154.8. Now we can apply the equation of the capitalized worth, P equals A over I. So this is A and this is I, 10%. So this is the capitalized worth. So you see, it's easy. You just need to get the value of A, and that's it. The second exercise, here we have the city of Greenville decided to build a softball complex on a land donated by one of the citizens. And here they have determined the costs included. We have an initial cost at $800,000. This is the initial investment. And the following are the annual costs. So we see we have annual upkeep cost of $120,000, annual utility cost of $13,000. So they are already annual. So this makes my work easier. I only have here the new renovation cost of $50,000 every 5 years. So we have to treat it as a future value. And we have some annual revenues of $32,000. So all these were costs, and only this one is a revenue, a plus value. So the city expects 40,000 visitors each year. What should be the minimum ticket price per person? Those 40,000 visitors will have to pay a ticket. And the ticket is a revenue, the ticket's price. We need to determine what should be the minimum price so that the city can break even. What do you mean by this word break even? When I say break even, this means that I want to find the value at the point at which my costs are equal to the revenue. I don't want to make any profit. Here, the profit equal no profit and no loss. I don't want to make any profit, but I just want to find the value that will help me cover all my costs. So what will be the ticket price that those visitors has to pay so that I can cover all my other annual expenses? This is what you'll have to calculate. Now, this is the given. initial investment, so this is at the present, it's $800,000. N is infinity, I is 5%, and these are annual costs and revenues, except for this one, it's happening every 5 years. Now here I didn't ask you what is the capitalized worth, I just need to find the value of X. So this means that I can use the annual worth or present worth and set it equals to 0, as we used to do. Set it equals to 0 to get the value of X. Here it's easier for me to calculate the annual worth because most of the values are in annual value, except for two values, which is the $800,000. This is the initial investment, it is P, so I will change it into A. And this one, which is the $50,000, which is the future value, so I will change it into A. I will put all the values in terms of annuity, put it equals to 0 to find the value of X. Now, how do I change this present value? A equals P, this is P, so the equation will be as if I'm calculating A. So A equals P into A knowing P, I, N. But here N is infinity. As we said, when I look at the table of interest, the factor related to A knowing P, 5% at infinity will be the same as the interest rate. So the interest rate here is 5%, so the value of the whole of the factor will be 5%. You can check it from the table again. This is already an annuity, annual upkeep cost. And remember, this is a cost, so you have to give it a negative sign. This is the utility cost minus $13,000. This is the $40,000 related to the number of visitors that was gonna come each year annually. So annually I have 40,000 visitors. And I will have to multiply the number of visitors by X, the price of the ticket, to get what here I'm getting revenues, amount of money that I'm gonna take. So this is the 40,000 X plus annual revenues of 32,000. So that's why it has a plus sign. Now this is a cost of renovation. This is the 50,000 happening every 5 years. So minus 50,000, this is F. So I'm gonna multiply it by the factor A knowing F. 5%, 5, because it occurs every 5 years. I'm getting this value from the table, it's 0.1810. Setting all these values equals to 0 because I agreed that the annual worth equals to 0. I will put it equals to 0 to get the value of X. I will get the value of X, which will be 3.75. So it's in the range between $3.5 and $4 for the price ticket for the visitors. So this was what's required. Now we still have one exercise left, exercise number 3, and this one I'm gonna keep it as a homework so that I can make sure that you understood the idea related to capitalized worth when the period of the project approaches infinity. Thank you for listening.